Hi everyone, welcome back to Pepcoding. I hope you all are doing good. So in this video, we are going to do one more question related to doubly linked list. And my question is remove after in doubly linked list. Okay, so let's try to understand this question first. In first line, what we have given, you are given a partially written doubly linked list class. Okay, you are required to complete the body of remove after function. So I have given one function and the name of that function is remove after. So this function is supposed to remove value after given node. So I have given one node and I have to remove the value of that node which is coming after the given node, right? Now, in third line, if size of list is 0, then return list is empty, okay. In fourth line, if size is invalid, then return index is invalid, okay. In fifth line, if location which we want to remove is null, then return location is invalid, right? In sixth line, we have given you are required to update head, tail and size, right? And in last line, input and output is managed for you. Just update the code in incomplete function. Okay. So for example, I have given this as my linked list. So this is doubly linked list, right? Now the question demand is I have given one node as reference node. For example, this is given as reference node and I have to remove the node which is coming after that node. Okay, so I have to remove this node. So I hope you have understood this question. If reference node is this, I have to remove this node. Okay, so this is the demand of our question. So now see how many cases are possible here. And before discussing the cases, you may have observed one thing. Size of doubly linked list or size of that linked list which has given to us cannot be 0. Why? Because we have always given reference node. So reference node is always present in our linked list. That means size cannot be is equals to 0. I hope you have understood till now. Now discussing the cases. So we can have three cases. And at first we have discussed size of linked list cannot be 0. So this case is not possible here. Here the second case is if my tail is given as reference node, then how can I remove my next node? We don't have next node now, so what we will write, next of reference node, if next of my reference node is equals to null, then we just need to print location is invalid as it is given in question and simply return -1. Return -1. You can see if location which we want to remove is null, then return location is invalid, okay, and size cannot be 0. And if index is invalid, simply return index is not present in my linked list. Okay. And now the third case is, see, if second last node is given as reference node, if second last node of my list, of my given list is my reference node, then at next of reference node we have this node. So here we have that node which we want to remove. That means the node which I want to remove or which is coming after the given node is present here. But if that node's next is null, then how can we handle this case? First of all, we will give name of this node as forward node, right? Now we have to remove forward node, but next of forward node is null. So one thing we have cleared from here, that my forward node is my tail. So we have cleared one thing from here. If next of reference node we have given, for example, we have given that node which I want to remove. Okay, but what if the next of my forward node is null? That means the node which I want to remove is at last position and it is my tail. I hope you have clear till now. So what we will write here, if next of forward node, if next of forward node is not storing any address, that means it is null. So my forward node is tail. Okay, that means my forward node, is my tail. Now what I have to do here, at next of reference node, because the question is I have to remove that node which is coming, which is coming after the given node, and the given node is reference node. So simply I need to write, or I need to cut this link, right? So what I will store at next of reference node, null. Okay, and in doubly linked list I have to break two connections. So at previous of forward node, you can see this node which I want to remove. So at previous of my forward node, I have to store null also. Okay, so that's how I can delete my node which is coming after reference node, because I have to break two connection. First of all, next of reference node should be null and previous of forward node should null. Okay, now I also have to shift my tail from here to here, because now this node has deleted, so my tail will come here. So simply I will shift my tail and decrease the size by 1, and I will also shift my tail to reference node now. So this is the case which is also possible. Now coming to the last case, 10, 11, 12, 13 or 14. Okay, so now if this is my reference node, right, that means I have to remove this node, but next of this node is storing address of this node. That means the next of my forward node is not null, so I have to cut this node, and after cutting this node I have to make this connection, okay, or this link. So how I can do that? See, for that, first of all, now I have to delete this node. I will make it as forward node, right? Now, so I am making my doubly linked list node. So here at next of reference node, I am storing my forward node. So after cutting this connection, if I want to cut this connection, what I have to do, at next of reference node, I have to store address of this node, and address of this node is here. Now that means at next of reference node, I have to store next of forward node, which is storing address of this node. Okay, so what I will do, at next of reference node, I will store address of this node now, and this node has stored next of forward node. So I will store address of 12 here now. So this way I will store address of this node. So at next of reference node, I will store next of forward node, which is denoting this node, right? Now I have to work for previous pointer also. What I will do for that, at previous of forwards next, forward nodes next is 12th node. So at previous of forwards next is denoting this node. So at previous For forwards next node, what I will store, what I have to store, this reference node. I hope you have cleared with this part. So at previous of forwards next node, which is denoting this node, here I have to store my reference node. And after that, what I have to do, at forwards next, because I want to cut this node also now. So for that, I have to store null at forwards next and forwards previous, so that this connection will get lost. Okay. So at the end, what I will do, at forwards next and forwards previous, I will store null. So by this way, this connection will get lost. Okay. So this way we can remove our next node, which is coming after reference node. So I have to work for these three cases in my code. So I hope you have understood till now. So let's move to the coding part. Okay, so first of all, I have to handle the first condition. Where function has given to us where we have to code. This is remove first. Okay. Yeah, here. So here we have to handle our first case, which is if next of reference is null. That means we don't have our forward node. We have to handle that condition here. Okay. If next of our reference node, next of my reference node is null, so I simply have to print system.out.println location is invalid, right? Location is invalid. Okay, invalid, and simply return -1 in this case. We will see what we have to return here. Okay, now I'm going to make one more private function here. Okay, and I will make my forward node there, and all the remaining cases I will handle here. Remove after node. Now node reference node. So first of all, I will make forward node here. Forward node, right? So my forward node is reference nodes next. Next of reference node is my forward node. Okay. Now I will handle here. Sorry. So what I have to do here is see if next of my forward node, that means if next of forward node is null, that means my forward node is my tail of the linked list. So forward node is tail. In this case, forward node is tail node. Okay, so what I have to do, simply at next of reference node, I have to store null, and at previous of forward node, at previous of forward node, I will store null and simply update my tail. So my tail is now my reference node. Okay. So as you have seen here, see, I have handled this case here. Okay. If next of reference node is null, that means we don't have any forward node. So we will simply print location is invalid and return -1. So that is our first case. Now coming to the second case. This is my second case. I have made one forward node. Then I simply check if next of my forward node, that means if next of my this, in this case my reference node is here, and forward node is here, right? If next of my forward node is null, that means this is my tail node. Now what I will do, simply at next of reference node I will store null, and previous of forward node I will store null, and simply update my tail. So this is what I have done here. So simply I have done this code here in my private function. Now if this condition is not true, then I have to go to my else block, and what condition I will write in my else block, let's see. Sorry. Now in my else part I will handle my this condition, right? So at next of reference node I will store for next of forward node. As you have seen here, this is my forward node and this is my reference node. So at next of reference node I will store next of forward, which is this. So at next of my reference node, what I will store, next of forward node. Then what I was doing after that, now at previous of my forward node, sorry, at previous of forward node's next node, that means at previous of my this node I am storing my reference node. So what I will do here, at previous of my forward node dot next, because this is our node which is coming after forward node. So at previous of my forward node's next node I will store my reference node, and at the end what I was doing, I'm simply storing null at forward nodes next and previous of forward node. So at forward nodes next and previous of forward node I will store null. Now after that what I will do, see, till here I have written all the three conditions which may possible in this case. First condition is this, second condition is this, and third condition is this. Now I have to return this remove after node here. So what I will do, simply return my private function here, remove after node. So remove after node and pass reference node here, and simply return the data, right? So let's run this code. So you can see our output has got accepted. Let's submit it. So we are getting correct answer. I hope you have understood each and every line of this code, because I have explained all the three cases which can be possible in this question. Thank you so much. That's all about this video.